setting up. And we will also start the recording. Okay, welcome everyone to the IPFS All Hands Call for June 25th, 2018. Kicking off the agenda today, we will be looking at, it looks like we don't have any agenda items to talk about. It's just going to be demos today. So the first demo is from Jacob here with IPFS Private Networks. Go ahead with that.
Share my screen. So this is, I'm not share my whole, all right. Well, we're just gonna do Wireshark first, since the proof is in the pudding with this one. So ultimately, we've had private networks working in Go for a while. And so now we've been working on the implementation in JavaScript. So what I have, and I'll push up the notes for the demo later so you can actually see the code. But right now what it's doing is taking the IPFS daemon controller and it launches a Go node and a JavaScript node and has them talk to each other. It dumps information into the Go node and then pulls that from the JS node. I have a public run that I'll show first with the network traffic, and then we'll show the network traffic of the private runner. So we'll kick that off. Then everybody see that okay?
Looks good.
Okay. So what you'll see in the network traffic is those initial connections of unencrypted. It's doing the multi-stream negotiation now. We can actually see it doing multi-stream, SecIO, and then it turns encrypted and turns into garbage because it's under the SecIO encryption. So the next thing we will do is I will just go ahead and restart this so it's easier to see. And we'll run the private connection. And the only difference between public and the private connection, actually setting those up, is that a swarm key file is included in the root of the repo. And so as long as that's there, both Go and JS will detect that it should be private, and it encrypts everything. All traffic is encrypted, except at the very beginning. You'll see here there will be a 24-bit nonce that gets exchanged on both sides. And so that is just right now, that is a hex 24. And so then immediately we see this 20 bytes, and that is one of the nodes exchanging multi-stream. So it's actually exchanging all of that encrypted. We see the other nonce get exchanged by the other node, and then from there on, everything is encrypted. There's no open data. We don't even see the protocol negotiation happen there. So that is fully functioning. Everything just needs to get merged, and I'm currently working through a issue with the JS pull reader because it's actually, it doesn't handle the encrypted stream very well when it's trying to negotiate var-ints. So I am working on a fix for that. And then once we have that, we'll actually have it so that when a private stream with a different key calls another private stream in JavaScript, rather than hanging on the connection because it can't figure out what it's supposed to be doing, it will actually just immediately fail, which is what we would expect. So that's basically it. Does anybody have any questions?
Yeah, I have a tiny one. Will this work through like in the browser through the WebSocket transport and all that?
Currently, it won't work through the browser because we have to have that swarm key file. So that's just a matter of, if we run it in the browser, where does that swarm key file exist, and without exposing it.
Okay, got it. Thank you.
But in terms of hooking it up, it could be included in an application, right? So if an application just wants to seal itself off from the rest of the world, it's not about being private. It could just have some way of like specifying the key directly in the configuration of a lib2p daemon or something, or sorry, of a lib2p node.
Right.
Any other questions before we move on here? Looks like no. So we have 2 demos up from Juan next. Go ahead and take it away, Juan.
Hey everybody, I was hacking in a couple of different things this weekend that I wanted to show. So I'll first show IPFS Sync. So 1 second. I'm going to be showing the screen here. So IPFS Sync is a small tool that I made in the command line a while back. And by the way, this is interesting. This is pretty cool, like GitHub notifications on packages being vulnerable and stuff. So this just appeared like in the last 5 minutes. So we'll see what that is. But yeah, it's cool that they're doing this stuff. I wish there was something much more like directly actionable. Anyway, so the Sync is a small tool built 1 part in Go, 1 part in JavaScript. The Go part is just some nice wrapping around another tool called Sync, which is just very simple AES encryption of a single file. And this IPFS Sync just takes some path in your file system, tarballs it, encrypts it with this Sync thing, adds that ciphertext to IPFS, and so on. So it's like just a very simple like porcelain wrapper around a bunch of other tools. Roughly how that works is, suppose that I have some thing here, some just file system directory with a certain set of files and some stuff. I can run, so I have this IPFS Sync tool that I can then run a command called share. So here in encrypt and send IPFS Sync share local source path, and then do it here. I'll like make this a little bit bigger. And so this comes out with a bunch of, so what that did is it tarballed the entire directory, encrypted it, added it to IPFS, and then gave me some helpful links. I guess there's some formatting issues. So this was there for a bit of time already, just so you can get a feel. This will just be some archive. Oh, interesting. That's, oh yeah, fail into counts. There we go. Wow, come on, Chrome, you can do it. Here, I'll just curl it because that's much more likely to. So this is just, well, I'll do localhost because I don't know if I'm connected correctly. So that's just some binary stuff. If I pull it down, that's just like a whole bunch of encrypted data. So then what IPFS Sync already gives you in that command line tool gives you the ability to download that archive. So if I did sync download, actually I need to add it again because I lost my keys by clearing the command line output. So the keys here, so the key that you use to encrypt, it uses a random key. You can also pass in a key if you wanted to with the dash key argument. The key that it used to encrypt it is printed here. I could use the IPFS download command as is described here to just output it. So if I did this, then it would decrypt it out into destination path. Now, the thing I wanted to show is this WebVR. So I'll show it again. And all of this is idempotent because it should be the same hash output. So this viewer is what I was checking on. So I'm using Companion, so it's like rendering, so it's diverting everything to be local. So this viewer is grabbing, so this took that archive and then decrypted it on the front end. So here's the IPFS path to the ciphertext. Here's the AES decryption key, and they are inserted into the URL under the anchor, which means that this won't be sent to the server. It will just be preserved with whatever the link is posted and the browser. So the browser has access to the key, and it shouldn't be sending it anywhere. That should stay local side. And what's up here, so this IPFS Sync address, here, I'll do it on incognito so that you can see it. This is just the simple viewer website right now. It's not loading anything because this shouldn't be going, but this is just the viewer. So it doesn't have any stuff yet, but I can easily copy stuff over. So I put the decryption key, put the path and press load, and this should pull down the stuff. It might take a bit of time. It might not be connected to it. So like my node might be behind an app, and so it's failing to view it. Oh, let's see, localhost. Connectivity problems today. There we go. So that is working from my local machine. So then you can view just various files. I guess this is the double encrypted thing. Got stuck in there. You can see text files and so on. You can see the source of files. So like you could grab an image and see the source. So I think this is taking a bit of time to render, but here's like the source of the JPEG. And then you can download individual files. So if it's an encrypted archive, you could click download, and then that downloaded that picture, and so on. And you can download the whole archive. So this will download the entire archive unencrypted. And so it's it just like decrypted it for me. So anyway, then this copies the link, and then again, this is the load page, and the code for it is here at this address. So IPFS sync. This probably should be moved to Shipyard. I just would like to find somebody who, if I move it, maybe I'll just move it. It'll be fine. And then you can see like a larger demo here. So this is, I think. So for some reason, I noticed a lot of things as I built this about the entire ecosystem and the tooling. So one interesting thing is grabbing things from the gateway is surprisingly faster than using window.ipfs. So right now, because Companion is on, it's pulling from window.ipfs, and that goes about 10x slower, maybe less, but compared to here, this will be without, I guess it's not much slower. I guess I was detecting just a drastically different rate. I think if I'm not focused on it, it won't download it. This is, I think, stuck for some reason. Anyway, the gateway works much faster. This is going through a local gateway. And this also has a, here's a much larger archive. All of it is in tarballs and so on. And you can even render video. So that is fully encrypted archives in IPFS with a simple tool. Now, this I should warn everybody, this is a random hack. Don't use it for anything serious, absolutely, and needs to be audited and so on. But this at least is an experiment of what it might look like to distribute entirely encrypted archives that are then viewable on the web. So the next steps from this is to reason about what does it mean to keep around like all these links with capabilities. That's not the ideal scenario. It works kind of okay for a small paste or something like that, but it's not ideal for anything much more serious than that. And it's also brought up an interesting way to do something we've wanted to do for a long time, which is have fully encrypted applications. So with this archive, what you could do is bundle an entire website and then have it encrypted, and then have the browser download the thing, decrypt it, and then render all of the pages directly on the client side. So now you have a fully encrypted application moving around. And so we're pretty close to that. I think we just need a bit more tooling to make that easy to do. But I think the heavy lifting is already there. The other side of this would be figuring out an actually proper way to do just all of the encryption of this stuff with, like, again, better key management and so on. Key management is going to be a really big thing in our world, and right now it's not entirely clear that this link is having a capability in it, and depending on where you put this link, then you're like revealing the entire contents of the key, right? You're revealing the entire contents of the archive by revealing the key. So any questions so far? I can't see everybody, so just speak.
Yeah, can we stop sharing, I guess?
I want to share something else right after this if you.
Gotcha. Any questions, anyone? I guess post in the chat.
Very cool.
And there's a thing called crypt paste, which, as you might imagine, paste from so I wanted to be able to paste things directly into an encrypted thing, and so now we have a way to like copy and paste and distribute like a paste bin with this. Great. So that is it for this demo. Should I move on to the next one?
I think so. Yep.
Cool. So the other thing I wanted to show is a tool called. So there was this long-standing repo from like many years ago. I guess 4 years ago was when it first started. It never quite worked. The idea was to create a bot on Hubot that gave you a pin bot. So after seeing a number of people on a Slack kind of struggle with pinning things and asking each other to pin stuff for them, I figured it was just time to make this thing. So I made this bot. It turned out to be surprisingly easy. And the entirety of this bot is inside this IPFS.coffee thing. Here's the list of commands that it supports. All of the ones commented out are not supported. You'll notice that it's mostly write. Anything that writes is not supported. It's just mostly reading and pinning. I guess pinning is technically writing, but everything else is like, you can't GC the repo. You can't do anything more of that. There might be a utility in doing that, but so far it's just read only. So here is I don't know if you can see. So if I have that archive from before, I can take the ciphertext, the path of the ciphertext, and then pin it to this pin bot. And I say, hey, pinbot, pin this. Is it gonna work? Oh man, is it not like alive? Oh yeah, that's right, I need to talk to it. So now it works as you would expect from the IRC pin bot. It just goes, fetches all the refs for that, and then pins them. I think I'm probably not connected to the rest of the world or something. So I am, my daemon is connected. Maybe they have a tool called push that tries to push refs into IPFS that I know is a total hack because otherwise sometimes it's just really hard for things to find me. And so this, if it works at all, it'll grab it. This might also be a bit large. Actually, no, it's small. So it's weird. All right, it finally pinned. So now it's there. You can also ask it for help, and that gives you just that set of commands that it supports. It filters out the ones that it doesn't support, and so it does everything else too. So you could do like, pin bot. You can ls thing it directly on there, and it'll give you the output. You can do a whole bunch of other stuff. Now, the interesting thing is it turns out to be quite easy to write all of these commands. Here's like supporting most of the commands is just forwarding the arguments and forwarding them and just taking the output and displaying it nicely. And then the goal for this is that right now it has Slack integration, but this is just a Hubot, a Hubot plugin. So this could work with all the other things that Hubot works on, including GitHub. So what would be really nice is to have a Hubot directly on GitHub that has some kind of authentication privileges. So that's the hard part on this, is like figuring out the authentication story. Same with Pinbot, I guess. But presumably what we could get to is a point where you could be in an issue and you could do something like, hey, it actually works now. But, so let's close that issue. But ideally, you should be able to do something like pinbot pin right here, and then have that actually work right on GitHub. And that, already a bunch of people use Hubot on GitHub, and this would probably speed up a lot of the people's development with a bunch of files and assets that need to get a pin and so on, especially for pull requests. Cool, that's it. Any questions on this? None. Great.
Very cool
Sweet.
stuff. Very, very. I'm excited to see the Hubot stuff with regards to our infrastructure and things like GX, so that pins don't get lost.
Yeah, seriously, GX.
That's the worst.
Yeah. So I think that it could work really well with GX. I guess there are some questions in chat. Jamie Wilkinson says, yeah, this is great. When feeling more stable, love to break it out into a package that can be pulled into other QBots. It already is that way. Actually, I guess it's not fully. Now, where's the other? Yeah, close it. I don't know how the plugin style for the repos works, but all it is this IPFS.coffee file. Everything is completely self-contained into that. So I think if you pull this into other QBots, that should work. Then Adam asked, does it support sharded directories yet? It does whatever IPFS does. So if IPFS doesn't automatically do sharded directories, then it does not. If it does, then it does. That is kind of like the wrong layer for the stack for that. Any other questions about QBot? Is that JS IPFS or Go IPFS? This is Go IPFS. So QBot is, here's where it loads the, it uses a gateway link. So paired with a gateway, then it'll work. It checks for a local gateway, and if there isn't one, then it uses the, no, never mind. It needs to talk to a local node. Where is the? Yeah, somewhere here, there's like a, it just expects, it uses IPFS API. There we go. Yeah, so it uses a local IPFS URL, which is defined here. So just expects a daemon running locally at the standard ports. And then, sorry, you can't see what I was looking at. It just uses just a standard ports for JS IPFS API, but it's expecting a Go IPFS daemon. It could be cool to try running it with an embedded JS IPFS node, but I haven't done that.
All right, I guess there's no more questions. Not seeing any. So if there's no more agenda items or demo, I think we can conclude for today. So thanks everyone for coming and showing off all these exciting projects. And I look forward to seeing everyone next week. Bye-bye.
See you.